Hello everyone. In this video we are going to discuss some of the prominent keywords in Java. We are going to discuss about the keyword static, super, final and abstract. Let's start with the first keyword, which is static. We use it static for a particular purpose. If we mention static before a method, which means that you can execute that method without actually creating an instance of that particular class. For example, if you are in a class called as example, and if you have a main method inside that example, we can, without creating an instance of example class, you can execute the main method. So that's why we use public static void main. So main method is static and therefore it can be invoked without creating the instances. So this is the first use case. So without creating the objects, you can access it. You can also use static keyword for variables, which means those are shared across various classes or various instances of the classes, which means in a way they are going to act like a global variables. So and also you can have static for blocks. So when you use static for a block, once again without creating instances, it first executes the block, and whatever is the content which is there, it gets executed. So we'll see one example of how static is used for all these cases. And also if you have a static in one method for a method in particular class, and if you want to access that from another class, you can use the class name dot method. So this is how these are the features, some of the features of static. Let us see with an example to better understand the keyword static. So here we have a class called as example static, which has two variables a and b, which are also static, and we also have a method meth, which is a static, and we have a block which is static, and finally we have a void main method which is also static. So let's see how this functions. So usually when we have a main method we usually have static precedes before main, which thereby without actually creating an instance of example static we can execute the main method. But since the prior to the main method we have a block and we have variables initiated as static, therefore they all get executed. So first we are going to see the output as this is static block, because it does not wait for an object to be created. So once it is a block is static, it just gets executed. And once after the static block got executed, here we have the main method which invokes the meth with argument 2. So meth is a method which is also a static method, and this static method has three outputs. It prints x, a and b. So here, since a and b are also static variables, as we have seen earlier, you can see static methods can access only static members, whether variables or methods. So here our meth is a static method and it is attempting to access the static variables a and b. So in this way, this is the first use case of static, where without creating an object of a particular class we are able to invoke the main method, and also we were able to execute the blocks. So this is the first use case. Let us go to the second use case, where we can, if we have two classes and if a particular method is static in one of the class, you can call that method from another class using the class name dot method. So here we have example static as the class, and class static is the second class. Class static class is invoking the meth method not by its object, by the class name itself. So example static is the class name and meth is the object inside, or meth is the method inside the example static. So usually we call methods by creating object and using object dot methods we invoke it. But here we are calling the static method meth using the class name dot method. So here the class name is example static and meth is the method. So this is the second use case of static. And the third use case of static is the variables acts like global variables. So here count is equal to 0. So across different instances of a particular class, this variable remains same, which means it can be accessed from various instances of class. For example, we have class counter, and this is the constructor for counter, and this constructor contains an increment of count, and we print the count value. So when in the class example 2 we have main method, and we created 3 instances of counter class C1, C2 and C3, and when we use counter dot display count, so here counter is a class name. So we already saw we can use class name dot display count because display count is a static method. So static methods can be accessed using class name dot method. So when you invoke counter dot display count, it will print the count values. So each time when you create an instance of this particular class counter, for example, like when you create C1, the constructor gets executed and count value increases. Since we have 3 objects, 3 instances, the count value has got incremented by 3 times. So across different instances of the counter objects, we are able to, across different instances of the counter class, we were able to access the count variable. So here count variable is acting like a global variable. So this is another use case of static. So static allows us to use a particular variable as a global variable across different instances of a particular class. So these are the 3 use cases of static. The first one is using, without creating the object, we were able to access the method, and we usually use it in main method. And the second is class name dot method. So when a particular method is static in a particular class, from the other class you can access by using the class name dot method. And the third case is the variables which are static can be accessed across different instances of a class. So these are the 3 use cases. Let's go to the next keyword, which is super. Super, we especially use it during in the concept of inheritance. So let us see what are the use cases of super. So as we all know, inheritance, one of the concept in Java, object oriented programming concept in Java, where we can inherit the methods and variables of the superclass into the subclass. So this super keyword allows us to refer to the immediate parent class instance variables or immediate parent class methods. So if we are in a subclass, you can access the parent class methods and parent class variables using the super keyword. And super is also very much used to invoke the constructors, to call the constructors of its immediate parent class. So for that also we use it. So let's see for each of those an example. So here we have a class example, and we have 3 classes here: example, class A and class B. Class B extends class A, which means class B inherits everything from class A, and class A has 2 constructors, one with argument and one without argument, and class B has 2 arguments, one without argument and one with argument, one with 2 arguments. So here, so when we are in the example method, we created an object of class B named as OB, and using OB we are invoking the meth B, which is a method inside the class B. So OB dot meth B will invoke the method which is written in class B. So when we invoke that method, so first this particular OB, when you create that instance of OB, when you create a OB, we have two arguments, 10 and 20. So these arguments are passed to the variables appropriately using the super keyword. As we saw earlier, super is used to call the parent class, immediate parent class constructor. So here, when we see the class B, we have two constructors, one without argument and one with argument. In the case where we have two arguments, int A and int B, we are using super of A. So this super of A is going to invoke the parent class constructor, and we are passing the value A, small a, to it, which means that the value A is assigned in the super class, in the parent class, which is A here. So as we can also see, the class A has the constructor with one argument. So when you are writing super of A, so it is going to call the constructor, the first constructor in class A. So thereby 10, the value 10 is going to be assigned to first A and thereby I in class A. And whereas value 20 is going to assign to small b in class B. So and later it is being assigned here to J. So thereby we get I and J values. So J is directly available in class B, so you can print it directly. Whereas to access I, we are once again using one of the concept of super. So super can be used to access the immediate parent class methods and variables. So when you say super.I, we are accessing the super class variable here. As you already saw earlier, in the constructor, I has been assigned with A. So using super of A, we assigned the value 10 to first A and thereby later to I. So super.I will print 10 and J will print 20, and within this constructor also we have I in class A, so it also prints first I in class A 10, I in class B 10, J in class B 20, and later this is meth A. So here this final super.meth A is used to demonstrate the third use case of super keyword, which is to invoke the methods of the immediate parent class. So meth A is a method with inside the class A. So using the super keyword, you can access the method of the parent class, and here it is printing this is meth A. So this is the use case of super. Super is used to access the immediate parent class methods and variables, and also it can use to invoke the constructors of the immediate parent class. So using the super keyword, we were able to invoke the constructor class of A in this particular example. So this is the second keyword. Let us now go to the third keyword, which is abstract, and later we will see the final. So abstract, this is also one of the concept related to inheritance, and the idea of abstract is, if you declare a particular class as abstract, which means you're not sure of how that method should be executed, and you leave it to the subclasses to be executed, and it is mandatory for the subclass to execute that particular method, or it is mandatory that the subclass should have a body, should have a complete execution or the methodology of how it is being executed. Whereas in the abstract class, we don't have the body of that method. We'll just have the name of the method, but the complete implementation of it is done in the subclass. And subclass, it is mandatory for the subclass to implement the method which is part of the abstract class. So as you can see here, any subclass inheriting from an abstract class must provide an implementation for these abstract methods. And if we don't do it, the subclass will also become abstract. So using abstract, we can make subclasses implement the methods, and the superclasses can just call those, give the name of the method without any implementation. This is very much useful in the practical use cases where we give the flexibility to user to define his method. So the second one, abstract classes cannot be instantiated directly, which means that we can't create an object of the abstract class. However, we know that superclass variables can be referenced to subclass objects. So you can create a superclass reference, which means you can create a reference to a abstract class and later you can assign to a subclass object. But we can't create an instance of abstract classes. So let us see this with an example. So here we have class figure, which contains two variables dim1 and dimension1 and dimension2, which also has a constructor with two variables a and b, and a method area which does not have any implementation. So we have abstract areas class which contain main method, and it has instances of rectangle and instances of t. So we also have rectangle class and triangle class towards the right side. So rectangle class extends figure class, triangle class extends figure class, and rectangle class has a rectangular constructor and a method area. Triangle class has a triangle method and a triangle method implementation method area. So when in the abstract areas class, we create instances of rectangle and triangle. Instance of rectangle is called as r, small r. Instance of triangle class is called as small t. And we also have a reference variable figref, which is a reference to the figure class. We know figure is an abstract class. We can't create the object for figure class, but we can have a reference variable. And here figref is equal to r. R is an object of class rectangle and rectangle is a subclass of figure. So a superclass reference, which here the superclass reference is figref, can be assigned to a subclass object which is small r. So figref can be assigned to r, and also figref can also be assigned to t. So this idea is same. Figref is superclass reference and t is a subclass object. So in this way, by having a reference to a subclass object, you can invoke the area methods using figref. So now figref has methods which are implemented in subclasses like rectangle and triangle. We can invoke it and we can print it. So that is what is happening here. So it will print area is figref.area. It implements the rectangle area formula, whereas in the next case area is figref.area will implement the triangle area. So using the superclass reference, even though figref is a reference to an abstract class and the abstract classes does not allow you to create instances or objects, but figref, we can use it for creating a superclass reference, use it as a superclass reference, and using that superclass reference we can invoke the methods of the subclass and thereby implement it. So this is one of the use case of abstract classes. Finally, we have final. Final is used for three applications here. Final is used to create the equivalent of a named constant. Usually constants does not change its value and usually notated using capital letters. And if you write a variable as final, which means that you can't modify the value of it. Final can also be used to prevent overriding. Final can also be used to prevent inheritance. So let us see some examples of it. So here if we see example final is a class which contains a main method which does not contain any body. A3 is one class. B3 is also a class which extends A3, but that is not allowed because here first of all the extension is allowed, but the method which is there in A3 class is declared as final. So we can't, although we extended A3 to B3, which means B3 has access to all the methods of A3. But since meth has been declared as final, we can't use to override here. So method overriding does not function if a particular method is declared as final. And also the final 3 lines where we declare class C3 and D3 extends C3. So here the C3 class is declared as final. So if a class is final, we can't create or we can't extend it. We can't inherit from a final class. So final will not allow you to change the variables, which the second use case is the final cannot allow you, does not allow inheritance. Final does not allow overriding, method overriding. So these are the three use cases of final. So this is a summary of all the 4 methods in Java. Thank you.